So today we're back to circles. So can somebody remind me of any kind of circle words from days gone by?
Sphere.
That's kind of related, but not.
Circumference.
Okay, circumference is a word we can talk about today for sure. Diameter is a word for sure. Radius is a word for sure. Radii is the plural of radius. If we had two of them, we could call them radii. That's true. Somebody describe where those are on my picture. Where would I find a radius or a diameter or a circumference?
Circumference is like the surface.
Circumference is the whole way around. For circles, the circumference is a synonym for what word? Other shapes have this word. Circles, we call this word the circumference because circles just get special treatment sometimes. What is circumference a synonym for?
Like around the...
Yeah, going around a shape has a word. Perimeter. Every other shape has a perimeter. Squares, rectangles, triangles, when you go around them, that's their perimeter. For circles, when you go around them, instead of the perimeter, it's called the circumference. I don't know why. It has a special word. Radius or diameter, where would those live?
I think diameter is off.
Diameter goes the whole way through, and it has to go through this little thing here that we didn't say yet today. That's the center. This dot that's in the middle is the center. We talked when we did the circle words about a tool that you use where there's like a piece of metal that you jab into your paper and then it has a pencil end and you can trace out a circle with that tool. What was that tool called? It's a C word. It's also used by the Boy Scouts in the woods, but it's a totally different meaning of this word.
Compass?
Compass. Okay, so a compass can be that north, south, east, west thing. That has nothing to do with circles. That's just a different meaning of the same spelled word. But the center is the point where you would jab the metal tip in, and then the circle goes where the pencil would trace the circle out. But if I go through the circle, all the way through the circle, through the circle, through the circle, and I touch the center as I go, that is called the diameter. Where does radius then live? That was the other word you guys draw. Any memory of where the radius lives?
Radius is half a diameter.
A radius is half the diameter, so it has to go from like where to where?
From the center to the top.
From the center to the circle. So if I draw in a segment like this, that would be a radius. And when we first did that, they asked you some questions like, if the radius is 5 inches, how much would the diameter be?
10.
10. Or they might ask you if the diameter is 16. If the diameter is 16, how much is the radius?
32. Oh, wait.
8. Because the radius is always going to be half. The diameter would always be,
Whole.
well, compared to the radius, it's
2
double,
more.
2 times. So that's all stuff we did before. There's nothing new there. What we are trying to do today is something new with this. What we're trying to do today is figure out the circumference of a circle. Does anybody know from elementary school life or other places, people and things, does anybody know how to figure out the circumference of a circle? It involves a very special number, I will say that. It's a number that I have not mentioned this year, but I think it's a number you've heard of, but are not probably super familiar with this number. It's a very unusual number. Anybody know what I'm talking about?
Infinite?
No?
365.
No? Okay, so here's what's up with this. When we go to figure out the circumference, we're going to multiply the diameter by this special number. So they've been sort of working on this for a long time in history. So Egyptians and Greeks and all those people, I can't tell you the exact history of this, but at some point in history, people would notice that if we measured the diameter of a circle and you measure the circumference of a circle, the circumference of the circle was like about 3 times as big, but not perfectly. Okay? But if the diameter is maybe like 10, the circumference would be somewhere around 30, because they're multiplying it about by 3. Okay, so you could measure this with a piece of string or measuring tape. If you've ever been to the tailor, you know they've measured your waist. I don't know if you've ever had to get a tailored suit or something, but you know they take a tape measure, they measure your waist, they see what it is. You know, you could take a string or a tape measure or something. You could go around the center of this. You could measure, like with a string, how far around that is. Straighten the string out, measure the string. But if it's about 10 through here, it's about 30 around there. People figured that out a long time ago, thousands of years ago. And then they gradually got better at that, and better and better and better. People later in history figured out it's not really 30, it's more like 31. And then people later figured out it's not actually 31, it's more like 31 and a half. And then they kept getting better and better and better because they kept figuring out this special number a little bit better and better and better. Does anybody know what number I'm talking about yet? It's a number with a name. It's a 2-letter name. It's a number with a symbol. It's a weird Greek symbol. Maybe you've never heard of this. I don't know. It's a strange number because it's a decimal number that never ends, but it also never has a repeating pattern. It's a decimal number that goes on literally forever without getting a repeat in it. Does anybody yet know what I'm talking about? Pi. So pi is spelled P-I, pi is how we spell pi. It's not like piece of pie like you get at the bakery. But P-I, pi, is the name of this. Does anybody know anything about pi other than some of the stuff I just said?
There's a lot when you, I think,
Let's try this. Does anybody know what the symbol for that looks like? They grabbed like a Greek letter for this.
it's like a music note, like you can think of it.
Maybe, I don't know. If you want to draw it, I'd look at it. I'm not sure what you mean. It a little bit does look like that. Anybody have a thought what the symbol for pi looks like while he's doing maybe a doodle?
Something like this.
Yeah, that's pretty good. So we can go, sometimes you see like an 11 with a flat hat on it. Sometimes you see, looks like an 11 with kind of a squiggly hat on it. That's not super important. It reminds me a little bit of Stonehenge, if you've ever seen that in England. It's like a monument with like these stones that stand up, and then some of them have like cappers on it. It reminds me a little bit of that. But the symbol for pi, it's kind of like an 11 with a hat on it. However you draw the hat is kind of like up to you. Does anybody know about how much pi is? Okay, so I'll say pi, this little squiggly equals means it's about equal to 3 1/7. Sometimes gets used by some people. Sometimes people will say 3.14. As far as I've ever memorized this, it's 3.1415927. That's what I know. There's people that know this to like thousands, maybe more of decimal places. I'm not sure why people want to do that, but I'm sure in the Guinness Book of World Records there's somebody that knows the most places of pi, and they could rattle off 100 or 1,000 or something of the digits. People have strange hobbies sometimes, but they do. Let me grab my calculator for a second. When you get up into the upper maths in the high school world and you start using like a bigger calculator, this calculator has a pi button. So this calculator knows it a little bit more than I do. Is 3.141592. It's actually a 654, and what I've done is I guess I memorized a rounded version of that, because when it's 5 or more, the 6 would go up to 7. So How many digits you use are kind of up to you, but here's the thing that you want to understand. No matter how many digits you grab, you can never get all of them. It's going to go forever. Pi is a non-repeating, non-terminating decimal. Doesn't repeat, doesn't end, goes forever. So if 3.14 is close enough to you, for you, use 3.14, and that's what we're going to use today. But if you were trying to like put a satellite in orbit around Earth, would 3.14 be close enough for NASA? No. 3.1415927 is probably not close enough for NASA. This is probably not close enough for NASA. They're going to want to go basically as far as they could go, and people can figure out more digits of pi if they want to. You could Google that if you're curious about the history or background of that if you want to, but I'm sure they know pi to probably millions of digits by now. And there's probably people working on computers to figure out what more digits of that are. But the Egyptians and those folks, they were probably happy enough with 3.14 at first, and then it's just gradually kind of gotten better over time. Here's just another thing to understand. Eventually there has to be some repeat of some pieces, okay? So sometimes people have trouble wrapping their minds around, what do you mean it can't repeat? They're looking at this like, well, it has a 1 there, it has a 1 later, that repeated. What do I mean? Why is this not an example of a repeat? Even though it has 1. Yeah, because this 1 got followed by a 4, but that 1 got followed by a 5. If I wanted to go look up on the internet the first 1,000 digits of pi, I could fill my entire board up with digits of pi if I wanted to, which I don't. At some point, would we get another 14 show up on my board? I sit here and I just write digits all day long. Is a 14 going to show up?
Yes.
Yeah, it has to, again, sometime. But this 14 got followed by a 15. And the next 14 might get followed by 17, or 28, or 93. There's a lot of other choices, right? If we wanted to, in the town of Cheswick, knock down all the buildings and build a giant blackboard that covered the whole square mile of Cheswick, and you start writing on that blackboard digits of pi, would 1415926 eventually show up as a pattern again?
Yes.
Yes. But this time it got followed by a 5, and maybe next time it got followed by an 8 or something else, okay? So there's not a true repeat. Some of the little segments have to repeat eventually because there's only so many ways you can create numbers, but there's not a true repetitive pattern. There's never a time that you're like, okay, long enough, let's put a bar on it, it repeats. That can't, it just can't, won't, doesn't happen. Even though little pieces repeat, it wouldn't. You could take the whole globe of Earth and sit there and write pi every square inch of the Earth, and you'd get a lot of repeat like mini patterns, but as soon as you think you found something that was this big, you'd realize, uh-oh, now there's a change, because here's this pattern, and there's a 2 this time, and the next time you do the whole pattern again, oh, there's a 3. Like, it doesn't repeat. You understand? Question about that, idea of that. I don't want to go too far down that rabbit hole. Like I said, if pi is interesting to you, just Google history of pi, P-I. Don't do history of pi, P-I-E. That'll tell you a little different story about bakeries and who knows where pi came from. I don't know. But P-I, pi, you know, I would guess the Egyptians and the Greeks and different people are going to get mentioned. But here's what we want to do with your life. For us today, they ask us to do circumferences. We need to know the diameter, and we're going to use 3.14. 3.14 is what we'll multiply by and just call that a day. So if I tell you that the diameter of a circle is 7, and I want you to figure out the circumference, you just have to take 3.14 times 7. Somebody do that for me? Either on your scratch paper or in your mind or talk it through on the board. Doesn't matter to me how we get it.
7 times 4 is 28.
Okay, so 7 times 4 is 28.
7 times 1 is 7 plus 2 is 9.
It is.
And 7 times 3
Is 21. And then we count everything to the right. How many numbers count? 2. So if we make the answer have 2, 21.98. Again, it's going to be about 3. Okay, if you want to use a bad estimate, use 3. So 7 times 3 is 21. It's got to come in bigger than that. Okay, so if I tell you the diameter is 8, it's got to be a little bit bigger than what? A little bit bigger than 24. 8 times 3 is 24, so expect something that's like 24, 25. Okay. So what's the exact math going to do? Well, exact-ish math do for us? How are we doing it?
3.14 times 8.
3.14 times 8. So 3.14 times 8.
Eight times 4 is 32.
It is
8 times 11.
11.
25.12.
25.12. We said we were expecting more than 24, 25 and some change. That seems right. Again, is this perfect? No. Why is this not perfect? Why is this, like, if we were NASA and we were doing space shuttles off of this, why are people not going to survive the trip?
Because it's infinite.
Yeah.
Pi is infinite.
Pi is more than that. You know, it's not 3.14. It's 3.14 and a whole lot of other stuff. Sometimes people use 3 and a 7th. Let me go back to that for a second. What's 1/7 from our chart base?
0.143857.
So you can see that's close too. The 1428 is actually a little bit too big. The 3.14 alone is actually a little bit too small. Neither of those is bad. Neither of those is perfect. They're both about equally good. So let's go one more time. So for this one, what are we going to do for the math?
3.14 times 6.
Ha, gotcha.
Divided.
That's a radius.
That's a radius.
Divided.
Ha 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 ha. Diabolical.
That's a scary laugh. That is kind of scary.
3.14 times 12. I do that because the book will do that. The book is going to occasionally try to trip you up. We want to know the diameter. They'll usually give you the diameter, and every once in a while, just to mess with you, they're going to give you a radius. If they give you a radius, how did we make that transition?
Double.
Double it. So take 6 times 2 is 12 for a diameter. 3.14 times 12. Let's scratch paper somebody, get it up, check back in with me. It's got to be bigger than 36. 3 times 12 is 36. Expect something that's like 36, 37, 38, something like that.
Times 2 is 6.28 times
1,140.
No, we're expecting something like 36, 37, 38.
Divided at
37.68.
Okay, so he says 37.68.
Yeah.
Somebody else chime in and agree or disagree with that. You say good, I say good as well. I didn't mean to, but I've like sort of by accident memorized some pi times tables. Like you guys, you memorized 8 times 7 is 56. You did that either on purpose or by accident over time. I know 3.14 times 12 is 37.68. 3.14 times 16 is 50.24. Like I don't know them all, but there's some that I just like by accident I just do them.
It's because you teach them?
Yeah, I see them every year, a couple times a year, so it's like, if you do 3.14 times like 20 or 30 or even numbers like that, I know them. If you do 3.14 times like 79, I don't know that one.
What about 3.1?
But if you do 16 or less, I might know most, if not all of them.
3.14 times 26.
I don't know that one.
What about 30?
30, I don't know that one, but I could figure that one out pretty fast. That's 94.3. Because the 14 times the 3 and 30 is a 42, so it's got to have a 42 at the end, and then 3 times the 30 is a 90, so sort of put it together.
Can I see one more?
There you go.
Okay, 3.14 times 14.
That's 43.96.
Oh.
Yeah, I do know that one by accident. If we're under 16, I'm probably good. But here's where we're headed. There's not a whole set of these. There's a page. So we're going to a page 297. So 297, there are some letters. We're just going to do all of it. 297, the letters will go A to whatever to practice this skill. The 1 to 25 practice all of our skills, which is a good day to practice all of our skills, because there's a quiz. So in the last week or so, we've done a variety of things like set OO, set PP, a little bit of rounding. We've been here, there, everywhere. So the 297 hopefully gives you a little bit of a review of rates, like that 55 miles per hour lesson that we did. Hopefully 297 reviews a little bit of stuff for you tonight. Tomorrow I can answer those questions quickly, but we'll do what we most frequently do, which is I'll give you one of those practice papers to just refresh what we did the last week, and then we'll take a quiz that's like the practice paper. Sure.
Christian, get the
Cut the record.